Hey everyone, and welcome. Today we're going to dive into a really powerful blueprint for teaching science. It's one that totally flips the script on rote memorization and replaces it with something way more exciting, genuine, hands-on curiosity. And it all kicks off with one big question. It really does start with a simple but super profound question, doesn't it? How do you take a subject that can sometimes feel, a little abstract or intimidating and turn it into a real lifelong passion? Well, the answer, it turns out, is all about rethinking the entire approach from the ground up. So, here's the core shift in a nutshell. On one side, you've got the old way, right? Memorize facts, passive listening, just knowing what something is. But the new way? It's all about investigating questions, getting your hands dirty with active investigation, and truly understanding the why and the how. This isn't just some small tweak. It's a real game changer for how we learn. All right, so where do we even start on this journey? Well, the very first step in our blueprint, it's all about igniting that initial spark of wonder. And in this model, you know what that spark is? It's always a question. This whole approach actually has a name. It's called inquiry-based learning. And the idea behind it is, well, it's actually pretty simple, but it is so powerful. Instead of just handing kids a book of facts, you're essentially turning them into little detectives. You're empowering them to ask their own questions, run their own investigations, and discover the answers for themselves. And just look at how simple and, well, real these questions are. There's no intimidating jargon, no complicated formulas here. It's just pure, raw curiosity. A question like, how can we make dirty water clean? That's not asking for you to recite something from a textbook. No, it's an invitation. It's saying, hey, come on, let's figure this out. Let's start building something. Okay, so a great question gets you to the starting line, but where the magic really happens is in this next phase, learning by actually doing. This is where theory stops being just theory and becomes something tangible you can see and touch. I mean, let's take that water filter experiment. This is not just some arts and crafts project, right? Every single step here is a piece of the scientific method in action. You're layering the materials, asking yourself, what do I think this sand is going to do? Then you pour the water through to test it out. And finally, you look at what you've got and draw a conclusion. You are literally thinking like an environmental engineer. And what's so cool is that this hands-on approach works for pretty much everything. You're not just dropping a toy parachute. You're actually experimenting with gravity and air resistance. You're not just watching a seed grow. You're uncovering the basics of biology right there in a little plastic bag. And even just flicking a ruler on the edge of a desk, boom, you're discovering the physics of sound. It's all about learning by doing. But, just doing experiments in a vacuum isn't quite enough. To really make it stick, to really inspire, you've got to connect it to the human story behind it all. Think about someone like Leonardo da Vinci. This quote is amazing. Even ideas on paper can change the world. And that's so true for him. He never actually built his parachute design, but the drawings he made, which just came from being curious about how air and gravity work, they laid the groundwork for people centuries down the road. It's such a powerful reminder that sometimes just the act of thinking and designing, that can change the world. And this isn't all just ancient history either. The explainer also brings up this amazing story of a modern scientist. She saw people in her own community getting sick from dirty water, and that inspired her to invent these super simple, affordable filters using materials she could find right there. It's just proof that science isn't some dusty subject in a book. It's a tool we can use to help people right here, right now. So, you've got the questions, the experiments, the inspiration from heroes. What does it all add up to? Well, this is where we get to the real goal. Because honestly, it's not really about building one perfect water filter. It's about building a scientific mindset. So while a kid is just having fun with an experiment, look at all the incredible skills they're building without even realizing it. They're learning how to design a fair test, how to gather and record what they see, how to compare different designs, and how to draw conclusions based on actual evidence, not just something they were told. We're talking problem solving, critical thinking. These are the building blocks for, well, everything. And that is the real transformation right there. You stop being just a passive observer, sitting back and watching science happen. Instead, you become an active participant. You're the engineer, the designer, the scientist calling the shots in your own investigation. All right, let's wrap this all up. Let's bring it all together. Why does this blueprint matter so much? What's the big takeaway here? Okay, here it is, the whole blueprint in one simple table. It's a 4-step cycle. Step 1, spark. You ask a guiding question to ignite that curiosity. Step 2, build. You get into a hands-on activity to really develop understanding. Step 3, inspire. You connect it to a real human story to create motivation. And finally, step 4, reflect. You analyze the results, and that's how you foster that scientific mindset. Spark, build, inspire, reflect. It's simple, it's powerful, and you can use it over and over again. And that really just leaves us with one last kind of mind-blowing thought. If we give the next generation these kinds of building blocks, a foundation built on curiosity, on doing things, on being inspired, what are the limits? Seriously, just try to imagine what they'll discover. What incredible problems will they solve? When you think about it that way, the possibilities are absolutely endless.